Hello everyone, I am Swarnima Singh, research scholar under the supervision of Professor Prabhakar Singh from the Department of Physics, IIT BHU, Varanasi. I am presenting contributed paper entitled Structural and Optical Bandgap Studies of CS SN half PB half PR3. Outlines are introduction, motivation, method of synthesis, absorbance and optical bandgap, XRD pattern of the samples, IV characteristic, conclusion and references. There are the two sources of the energies, the renewable sources of the energy and non-renewable sources of the energy. Renewable sources of the energies are derived from natural processes which are replenished constantly. But the non-renewable sources of the energies are limited in the amount and can be exhausted at a time. So there should be an alternative of the non-renewable sources of the energy. These are the few data which shows that approximately 80% of the world energy is produced by the fossil fuels. So in order to fulfill our energy requirement, there should be a suitable and reliable alternative of the non-renewable source of the energy. There are 5 major types of renewable energy sources, which are wind power, geothermal energy, biofuel, hydropower, solar energy. My area of interest in my research is solar energy. Solar cells are the devices which can convert solar radiation into the electrical energy by the means of photovoltaic effect. This DC electricity can be stored in a battery and which can further be used in the absence of the solar radiations. There are the several materials which are used as active layer of the solar cell. In that series, perovskite are the materials which are popularly used as light harvesting active layer of the solar cell. Why am I talking about the perovskite materials? What are the good properties about the perovskite materials for the active layer of the solar cell? It has high charge carrier mobility, long charge carrier lifetime, high open circuit voltage, and the band gap of the perovskite materials can be adjusted or tuned by mixing the halide perovskites. And in the case of perovskite materials, the fabrication is also of low cost. But there are some limitations about the perovskite materials, which are about the stability and photostability. My motivation of work about the solar energy is, as we know that the CSPB-BR3 is a perovskite material which is toxic in nature and it triggers the pollution in the atmosphere. So in order to obtain the environmental friendly perovskite material, I want to replace this PB to the tin atom. So in order to replacing the PB atom with the tin atom, I want to replace it in a series by changing the concentration of SN and PB partially or completely. When the concentration of PB is changed and the SN atom is introduced, the band gap will be the tunable of the material. Method of synthesis. My method is solid state reaction method. I have synthesized these 3 materials below the room temperature and I have done grinding for 2 hours in air atmosphere. My precursors are CSBr, PVBr2, SNBr2 and I have prepared these 3 samples for the comparative study of CS SN half PV half BR3. This is the plot of UV visible spectra of the samples that I have prepared. Here we can see green one is corresponding to CSSN BR3, red one is corresponding to CSSN half PB half BR3, and black one is corresponding to CSPB BR3. Here we can see only two peaks were observed in the plot of CSSN BR3 and CSPB BR3. The peak in CSPB BR3 is obtained at 365 nanometer, and the peak for the CSPB BR3 is obtained 530 nanometer. But in the case of SN half PB half BR3, that is when the concentration of SN and PB are equal, there are the two peaks in the UV visible spectroscopy. So these two peaks were arising from pi to pi transition and n to pi star transition. This transition sigma to sigma star is not possible in UV visible spectroscopy because it requires larger amount of energy. The transition corresponding to pi star and n to pi star are the only transitions which are occurring in UV visible spectra. This peak is corresponding to pi star transition, and this peak is corresponding to n to pi star transition. This is a top plot of the samples that I have prepared, and I have calculated the band gap for these three samples using the top theory, and I have obtained the band gap for CSPB BR3 is 2.24 electron volt. For CS SN half PB half BR3, the band gap is 1.83 electron volt, and the band gap of CS SN BR3 is 2.74 electron volt. Here we can see that when the concentration of tin and PB are in the equal amount, the band gap decreases. This happens due to the increment in the concentration of SN. When it increases from 0 to 0.5, the spin orbit coupling between SN atom and PB atom increases, and it will lead to the splitting in the energy level, which gives the narrower band gap. This is the XRD pattern of the samples. This is corresponding to CSPB BR3. This is corresponding to CSSN BR3, and this is corresponding to CSSN half PB half BR3. In this XRD pattern, I have done indexing using JCPDS file, and I have obtained the CSPB-BR3 in the orthorhombic phase and CSSN-BR3 in cubic and monoclinic phase. But the sample CSSN half PB half BR3, that is having the equal concentration of lead and tin, is in the composite. It is a composite material, and we can see the peaks in the composite material are less have less intensity as compared to the CSSN-BR3 and CSPB-BR3. It is because due to the less periodicity as compared to these two parent compound. I have done I have located some measure peaks of CSSN half PB half BR3 for the orthorhombic phase and cubic phase. So here we can see that the most of the peaks are corresponding to the orthorhombic phase and few peaks are corresponding to cubic phase. This is the IV characteristic of CSSN half PB half BR3. The IV characterization is done in both light and dark medium. Here in this plot, we can see the plots corresponding to light mode and dark mode are coinciding up to 2 volt, and gradually the separation between these two plots increases. It suggests that there is almost no change in the trap density in the AM 1.5 G sunlight. However, small increment in the current is observed. And this plot also gives that the sample CSSN half PV half VR3 shows good photo response. Conclusion. I have calculated the band gap by using the talk theory, and I obtained the band gap of CSPB BR3 is 2.24 electron volt and CS SNBR3 is 2.74 electron volt. But when the concentration of the SN and PB is equal, there is a narrower band gap is obtained, that is 1.83 electron volt. The XRD pattern of the CS-SN half PB half BR3 is in the mixed phase of orthorhombic and cubic. These are my references. Thank you.